Question 895, maximum frequency stack. Design a stack-like data structure to push elements to the stack and pop the most frequent elements from the stack. This freq_stack class constructs empty frequency stack. Push an integer value onto the top of the stack. Pop removes and returns the most frequent element in the stack. If there is a tie for the most frequent elements, the elements closest to the stack's top is removed and returned. Example 1. We first initialize a new stack, and then we push value 5, push value 7, we push value 5 again, and then push value 7, and then push value 4, and then 5. And now this is the stack. And then when we pop 5 because 5 is the most frequent element in the stack. And then after pop, the stack becomes 5, 7, 5, 7, 4. And we pop again. In this time, we return 7 as there is tie between 5 and 7, and then 7 is closest to the top of the stack. And then after that, the stack becomes 5, 7, 5, 4. And we pop again, return 5, because 5 is the most frequent. Now the stack becomes 5, 7, 4. And then we pop again, we return 4, as 4 is the closest to the top. So basically, compared to the regular stack, the push function remains the same. However, for pop, every time we pop the most frequent element in the stack. So how to solve that? So basically, the first question we ask ourselves is how to track and update the most frequent element as we pop or push elements. As you can see from this example, as we are pop and push elements, the most frequent elements also get updated. So step 1, we need to count for each element. Basically, we need to track the frequency of each element. We use the frequency self.frequency. It's a hash map. The key is the value, and then the value is the corresponding frequency. Basically, how many times these elements occurred in the stack. As we are pop and then push elements into the stack, we also update the count in this self.frequency. Okay, so now we know the frequency for each element. However, how do we pop the most frequent element? So the most intuitive or straightforward idea on top of my mind is I actually use a variable. Let's say use something. So some idea, let's say, for example, use a variable, let's say max frequency. And then I need to track, let's say, what is the maximum frequency right now. But how do we update it if we use a single value? Let's say when we add elements, let's say when we push elements to the stack, it's easy to update its maximum frequency. Basically, every time we update the frequency map, we just compare the new frequency with this max frequency. However, we are trying to pop the elements. Let's say, what if, let's say, we have 3 most frequent elements. And then when we pop one of the elements, we still have 2 other elements with that frequency. So in that case, the maximum frequency is not updated. Then how do we know we still have elements with that maximum frequency left? So in that case, so the question we ask, how do we know? How do we know there's still elements with maximum frequency left? So basically after pop, so this is the question we ask ourselves. So one of the idea is we actually to track, okay, to track how many elements. Basically, we track a list of elements with the maximum frequency. So let's say right now we are tracking the maximum frequency, and then after pop, how do we know if there are still elements left with that maximum frequency? So in that case, we also need to track a list of elements with the maximum frequency. But however, after multiple pop, what if we pop all the elements with the max frequency? Okay. So in that case, we need to update the max frequency. Then after update, how do we know, okay, what are the elements with this updated max frequency? Then we need to also track a list of elements with this updated frequency. So in this case, we actually need to track a list of elements for each frequency. So basically, how we arrived at this conclusion. So basically, we need to know what are the elements, most frequent elements. So in that case, we need to track the maximum frequency. So for each pop, we return the elements corresponding to the maximum frequency. But how do we know if there are still elements with the maximum frequency left? Basically, we need to answer this question to know, okay, if we need to, whether or not we need to update this maximum frequency. So in that case, we need to track a list of elements with the maximum frequency. If that list is empty, then we know that there are no elements with that maximum frequency left. So however, the next question we are considering is, what if we pop all the elements with the maximum frequency? That list becomes empty. In that case, we need to update the maximum frequency. And then after update, what are the elements with this updated maximum frequency? Because we also need that information for the subsequent pop. So in that case, in order to know that, we need to track a list of elements with this updated maximum frequency. So in this case, as we can update this maximum frequency, the easiest way is to actually track a list of elements for each frequency. So that's kind of lead to the second part. For each value of the frequency, we track the corresponding elements. We have a self.stack. It's also a hash map. The key is the frequency, and then the values is a list of values with this frequency. So in that case, we can know what we are actually, what we need to pop as we pop the most frequent elements. How do we update this frequency? Let's say when we update the frequency, we do not remove, only append. What does that mean? It means, let's push the values, a list of ones, onto this stack. So in this case, our self.stack should become this. So for frequency 1, we have element 1. For frequency 2, we have element 2. So that is how this is formed. Let's say when we first push the first ones onto the stack, we get the frequency 1, and then the corresponding list consists of this one. And then as we add the second one to the stack, so in this case, we update the corresponding frequency of this element 1 to 2. And then in this case, for the frequency 2, it has an element. So, but in this case, we do not remove the previous entry in this stack. Why we keep the previous entry? Why we form a stack like this? That is because as we pop, for example, when we pop the elements, we know right now the maximum frequency is 4, and then we pop these elements, and then we call the pop function again. So in this case, we know the maximum frequency is updated to 3. And then we still have the elements, that's 1 we need to pop. So that's why we keep it as we inserted into this stack. So basically, when we are updating the frequency, we just append the elements to the list for the updated frequency count, but we do not remove it from the previous frequency entry. So in summary, when we push the values for consecutive ones, we get a self stack like this. So this is actually the most critical part for the solution. After we figure out this part, so the solution actually becomes super easy, very easy. So how do we figure out the second part? The line 9 to line 15 is the thought process. Okay, so the third part is actually track the value of the maximum frequency that we already talked about. So for each pop operation, so basically we pop the elements and then we also need to update its frequency mapping. So that's kind of the idea. So let's recap this idea. We track the frequency for each element because we need to know the most frequent elements. So we need to know the frequency for each element. And then we also need to track what is the maximum frequency so we can find the most frequent elements. And then to track the maximum frequency, after pop, the question we need to answer is how do we know if there are still elements with the maximum frequency left? So in that case, we need to track a list of elements with that maximum frequency. What if we pop all the elements with maximum frequency? We know that, okay, that list becomes empty, and then we know it's time to update this maximum frequency. After update, if we call the pop again, so what are the elements with this updated maximum frequency? So we need to answer this question over and over again. So in that case, we need to track a list of elements for each frequency. So that's kind of why we construct self.stack data structure like this. So let's code the solution. We have self-max frequency. Initially, we set that to 0. We also have self-frequency. That is a dictionary. So let's use the from collection import default dictionary. This is default dictionary of integers, and then self.stack is the default dictionary of the list. And then for push, so basically when we push it, self.frequency value increase by 1, and then if and then self.stack this self.frequency value dot append the value. And then we also need to check self.max frequency is just the maximum between self.max frequency and then self.frequency value. When we pop, we need to return the most frequent elements. So in that case, we look for our most frequent elements, self.max frequency dot pop. So we pop the most frequent elements. And then after that, we check if self.stack self.max frequency. If it's empty, then we know that we need to update the maximum frequency. And then after we pop, self.frequency value. So this value we are popping is self.frequency value. We updated its frequency in the frequency table. And then we return this value. So actually we need to put this one outside the self.frequency. So basically after we pop this value, we update this frequency, and then we check if there's still elements with that maximum frequency. If there's no other elements with that maximum frequency left, we need to update this maximum frequency. Okay, so this is our solution. So let's recap it by looking over the code. So we track maximum frequency, and then we track the frequency for each value inserted onto the stack. We also have our stack, which is the hash map, and then the value is the frequency, and then the key is the frequency, and the value is a list of values pushed onto stack with that frequency. And when we update this frequency map, and then we also append that to the stack. Basically, for the corresponding frequency, it has this element's value. And then after that, we update maximum frequency. And when we pop the elements, the most frequent elements. And then we update the corresponding frequency count. And then if there's no other elements with that maximum frequency left, then we need to update this maximum frequency. So this is our solution.